starting recording now. Okay. So how does a computer boot? Boot means a starting process. We call it as booting. Okay. Let's say this gets started. So once you press the power on button or SMPS power supply button on your computer, okay. Now you have chipset, okay, BIOS or UEFI. Okay, I will tell you what is UEFI later. Okay, BIOS, what BIOS will do, basic input output service. It will check everything in the motherboard, how many devices are connected, keyboard, mouse, your all devices. It will check. Okay, it will check on the power on self test. It will do. You see it here, post. Post is power on self test. It will do. Then it will see, okay, I have everything now. Then bootloader will pass. Bootloader will get loaded. You will have first stage 1 booting here. It will be very small. Some KBs it will be. Stage 1 it will load here. So then it will recall the OS. It will load the OS from the hard disk. Okay. So once the bootloader is loaded in the hard disk, it will either boot into Windows or Linux based on your whatever installed on your operating system on your hard drive. It will boot. This is how the booting will work. Understood? This is the step-by-step process.
That's it.
How booting will work. Okay. So you have two types of booting here. Okay. You have cold booting and warm booting. Warm booting is like you are just pressing a reset button, or you are just harshly powering it on. That is called warm booting. Cold booting is you are going to switch it off completely, or you are gracefully starting the computer. That is the cold booting and warm booting. Okay. So again you have three types here computers. One is PC workstation. PC is personal computer, and workstation is a bigger model. Okay. So you have mainframes where you will have high computers, high-end computers, and then you have supercomputers. Okay. So this is very old. I will get the latest diagrams. Okay, you have input and output devices. So this I will going to skip it. Okay. Now you have how to read CPU specification, clock speed, core per threads, cache, what matters. So how you are going to select the CPU. Okay. So you have CPU now. So cores per threads. Okay. Clock speed. So clock speed is something like CPU clock speed. Okay. Let's say this is your railway engine. Okay. Let's say your railway engine, it can run up to 500 kilometer speed. I will give you my example. Okay. So my CPU can run up to 500 kilometers. Okay. Whereas I have the track which will allow me only 80 kilometers to run. Okay. So now, will this run faster or slow? See, I have a engine of capacity 500 kilometers. This will run up to 500. I can take it to 500 kilometers. So, but my track is limited to 80 kilometers. It will not run, right, obviously. Yeah, Pranav?
No, sir, it will not. Because there is a limit set.
Uh,
It will not run, sir, because there is a limit set over there.
that is how it will be. If your CPU is on higher, then your RAM should be also on the higher speed. Okay. So that is how the clock speed will be. Okay. So the more clock speed you have, the higher your CPU will be. So whenever you increase your higher CPU, you need to match up the RAM also like that. Okay. That is how the correlation is. So cores by threads is, if you have more, then you will be doing it more throughput. Okay. Like graphical will be running much faster with this course. Now you have L2, L3 cache. Okay. So the more you will have it, you will have a much speed. Okay. If you have bigger L3, so L2, L3 cache will be smaller only. Okay. L3 will be little bigger based on your budget. Okay. L3 will be boosting the gaming budget. Okay. This is how you will be looking at the specification. Now you have RAMs here, type of RAMs. Okay. So based on the pin levels, pin numbers here, you will identify what type of RAM you are having. 240 pin DDR2, 240 pin DDR3, DDR2, 240 pin, 260 pin. These are all the types. These are very old. Now DDR5 you will have much more pins here. Pin means smaller one here. You see it here, the small pins. Okay. So these many pins you will have, and you will be attaching it to the computer. The more you have, you will have the higher speed. These are just the colors, just the random colors. Okay. DDR, then DDR2. You see that here, DDR2, then DDR3, then DDR4 here. So now we have DDR5 type of RAM. This will be your track engine. Okay. CPU, you just think CPU like your railway engine, and this RAM is your track. So if you have high end, then you need to have a good track also. I will just see what are the prices here. I will see DDR5 and DDR4 price. You see DDR5, 5200 to 5600 megahertz. You will have up to 2850 to 13,000. Whereas DDR3 I can get from 750 to 2500. Roughly it is 1800. Okay. This is for 8 GB module. Okay. And for 16 GB and 32 GB it will be very high. Okay. 32 GB you see one slot roughly 44,000. Okay. So this is how your speed will differ. 5 to 5200 megahertz. Okay. Let's say what is my memory here. You see 800 here megahertz. Even though I can run up to 1400, still I am running at 800 megahertz. My CPU. Okay. these are all your RAM pins based on the type. DDR2, 3, 4, 5. The more you have DDR4, DDR3, okay, you see the performance also. 800 million transaction per second. So this is 1.5 and this is 1.2 voltage, supply voltage. This is fixed and it is programmable. You can program it. 2 GB to 16 GB you can have the density. Okay. Maximum you can have one RAM slot, you can take only 8 GB max. This one you can go up to 16 GB. DDR5 you can go up to 32 or 64 GB. Okay. I am not sure about 64, but definitely you can go up to 32 GB. DDR5. This is how the connectivity will be. So now you see the type of motherboards. Okay. Gigabyte, processor. You see these are all PCI slots. This is graphic slot. This is your RAM. This is your CPU. This is the chipset. Here you will have a heat sink. Here you have the chipset. Then you have the heat sink here. So you see all the boards. North bridge and this is south bridge. MSI. North and then south. Process. Biostar. Now coming to the storage part. Okay. Storage is like you will have multiple types of storage here. So you have regular normal HDD. Now you are not seeing these type of drives now. Okay. So you have a regular SSD, solid state drive, and then you have NVMe SSD. Okay. So we'll see that how those drives will look like. This is your HDD hard disk drive. You will have platter, and then you will have a spindle here. You will have read head. All you will be seeing this. Okay. On the HDD 3.5 inches. This length will be 3.5, and this will be 2.5. Okay. So you will have very good speed as compared to HDD here. I will skip this part. HDD, SSD, and NVMe. So we have in lab we have NVMe for the desktop, SSD for the laptop. We'll see how that will be configured. Now you have similarly hard drive. You will have much speed. These are all your NVMe devices. This is how they look. So these are the interfaces. So you want me to show the interface how it will look like. These are the interface. This is how they are connected. These are the interface. This is SATA and this is SAS. These are the pins that will be connected. Okay. So now you have PCI, PCIe, NVMe. Okay. This is how you will be connecting. Okay. You have slots here. You will be connecting. So interface version also, if you want, you can see that interface version PCIe 2.0. This one will be 2.0. You will be attaching it here. That drives you will be attaching it here. So you will take this hard drive and you will keep this here. So here you will be mounting it and you will be attaching it to the PCI 2 interface. I will copy this image. PCI 2 into 4. Into 4 I will say. Into 4. So this is one interface, PCI E1, 2 and 3. Okay, you can put it in any slot, PCI 1, PCI 2, PCI 3 like that.
Sir,
Yeah. Yeah, Pranav.
sir, to be honest, it's little going above my head, some of the things.
Okay.
I'm really not understanding what is actually going on.
I got it. See, if you, in the next class, once I open up the motherboard, okay, you should not ask me what is this NVMe, okay. This is your hard disk. You are seeing this stick, right? This stick you are seeing in the green here, that is your hard disk here, this one. This is one side and this is back side, okay. You will be attaching it to this card, okay. This card you will attach it here, okay. And this card you will put inside the motherboard. Okay. Now you have connected the hard disk now. There is no hard disk here like this. Okay. Normally you will have hard disk kit, right? Like this SSD and HDD. You will have hard disk, right? Have you seen these hard disks? Let's say I will open up the HDD.
Right.
Okay. I will open HDD. So you have seen this type of hard disk? Yeah, Pranav, you have seen this, right?
Yeah, I guess I've seen this.
Okay. This is your HDD. Okay, here. This is your HDD. Okay. So whatever you have installed is SDD. Okay.
Okay.
This is what you have installed inside your laptop, right?
Right.
Okay. This is higher as compared to HDD. Okay. If you compare it with the HDD, this one will be 3 times or 4 times faster. Okay. Now your laptop is not compatible with NVMe SSD. Okay, this is also one type. So this is also hard disk. Okay. So you are aware of it or not? If you are not aware, also no problem. Okay. So this is the latest one that it has come in the market. Okay. 500 GB. This what you will put. If you don't have that interface, you will buy this interface card, PCI slot like this. Okay. Here you will insert that. Once you put this card, you will get this hard disk. Okay. That is how it is. Now you have SSD form factor. SSD form factor is how you are going to connect. Okay. Let's say SSD form factor M2. So now in the next class I will open the hard disk, computer. You need to tell me what and all you have noticed, you have seen all that. Okay. Now you see it here. I will copy this. Now you have interface here. Okay. These are the form factors. How you will be connecting this. Okay. This will be M2 and this is M SATA and this will be U2. Okay. These are all the connectivity ports. Okay. If you go here, so it is giving me bigger diagram, then you can see it in a clear picture. You see. So these all will be having higher speed. Okay. You see it here, 6 GB per read, per second it can read 6 GB. Sequential write it can write up to 5 GB it can write. Right. Okay. So this is for your AI, high-end workloads, all that. It will be useful. Let me paste this one. Now you have clear picture here. So those are all your interfaces, how you are connecting to your motherboard. That's it. Now you have. So interface either SATA or PCI. Okay. You go ahead here. What is SATA or PCI? SATA will be like this. SATA interface. This is your SATA. Okay. So this is how you will be connecting. Okay. PCI will be like this. This card. Okay. These are all your PCI cards. So this is how you will connect. Like this. This is 1, this is 4, this is 8 and this is 16. So this depends on the speed, how speed you want to connect. So once you see that, you will understand it. Okay. See here only you have it. How you will be connecting. So this is how you have connected your hard drive, SATA. okay, inside. So if you had this interface, you would have connected the NVMe drive itself in your um, laptop. So those are all your interface. Now you see the difference, how much HDD and SSD and your NVMe. So you have 3 GB per second speed here. So here 500, you are maxing out at 500. That is why whenever you have a high end speed, it will operate it like this. Okay. So these are all your again interface, how you are connecting all that. So this we'll see in the next class in the hardware, we'll see that in the next class. So what we'll do, we'll take the break and I will come back. I will come back for Linux, then we'll start the Linux part. Okay. So I don't want to discuss on the RAID part. Okay. RAID again it will take time. Okay. Next in hardware class I will cover the RAID part and then power supply. In the hardware part I will cover all this. Okay. You have this motherboard, power supply, then you have coloring, 12 volts, 3 volts, 5 volts, all that. So one device will require one type of power. So you have type of NIC cards, wireless and wired, USB NIC. There is the server card.
Sir, excuse me, sir, can I ask one question?
Yeah.
Sir, in RAID, ESXi vSAN environment, which RAID is mainly used?
vSAN, RAID.
In vSAN environment, there is no RAID configuration needed, right?
So vSAN, all RAID configuration will be done by the vendor. Okay, you don't have to configure anything. Okay. That will be managed by your VMware vendor. You don't have to worry about that. So I believe it is RAID 6 or RAID 1.0. Okay. In the next class, I will cover this part. Now what we will do, we will take a break. Okay. Then we will come back to those commands. Okay. You just get ready with your putty sessions. Okay. So I will connect the putty and then I will run through all the commands. Okay. Start to